Welcome back. Previously, we have discussed about the concept of correlation and the various cases that comes under the same category. So let us discuss about the next area that comes under the same module, regression or regression analysis. Regression analysis. The correlation and regression analysis go side by side, because in correlation we study relationship between two or more variables, whereas in regression analysis, if there exists a relationship between variables, and by using regression analysis we will be able to identify the value of an unknown variable on the basis of a known variable. That is a simple concept and difference between correlation as well as regression. So, the prediction or estimation is one of the major problems in almost all sectors of business as well as human activity. The estimation or prediction of future production, consumption, prices, investment, sales, profits, income, activities, revenues, etc. There are a number of factors for which, as a businessman, we need to predict or we need to forecast so as to plan accordingly. So, prediction is of great importance to the manager or a businessman accordingly. And regression analysis is one of the best scientific technique for making such predictions. That is why we are learning regression analysis in our semester. So, what is the meaning of regression analysis? Regression analysis in the general sense means estimation or the prediction of the unknown value of one variable from the known value of the other variable. It is a statistical device used to study the relationship between two or more variables that are related. So, what is meant by those two or more variables? So, let us go into that part. In regression analysis, there are two types of variables, that is, dependent variable and independent variable. The variable whose value is influenced or is to be predicted is called dependent variable, otherwise known as unknown variable. The variable which influences the value or is used for prediction is called independent variable. For the time being, we are using B. So, the simple difference between dependent and independent variable is usually independent variable will be a known value and dependent variable will be unknown. So, with the help of the non-independent value, we are able to identify the dependent value or the unknown value. One value will be known by us, other will be unknown. So, we will be using the regression analysis to identify the value which is not known by us. That is the concept of regression. So let us discuss some of the different types of regressions. Mainly simple and multiple regression. On the basis of number of variables, regressions can be classified into simple and multiple regression. When there are only two variables, the regression equation obtained is called simple regression equation. And regarding here the term, you can see that equation is being used. In regression, unlike the correlation method, in regression you will be identifying an equation. Usually it will be two equations, sometimes it will be one equations. The first and the foremost thing is that you need to find those equations, or you need to develop those equations, and on the basis of those equations only you will be identifying the answer. But usually in correlation, you will be directly identifying a value or a numeric term. In here, you need to develop equations. Usually, two types of equation will be there because our analysis is always based on bivariate analysis, that is studying a relation between two variables. So we will be creating two equations, and on the basis of two equations you will be identifying some numerical value. So in simple regression there will be two variables and the regression equation obtained is called a simple regression equation. In multiple regression analysis there are more than two variables and we try to find out the effect of two or more independent variables on one dependent variable. For example, if there are three variables, for example, if I am a cultivator or agriculturist, I usually used to study the yield, rainfall and temperature. So by using regression, how I am going to use this regression analysis? So for time being, suppose yield is depending on rainfall and temperature. Then we get the relationship between or regression equation of yield, rainfall and temperature and its interrelationship between all these three variables. That is the concept. You will get a clear picture while doing the application level question. Anyway, remember in regression you will be developing equations and on the basis of equations you will be identifying or finding out some numerical values. Next one, linear and non-linear regression. On the basis of proportion of changes in the variable, regression can be classified into linear and non-linear. If the given bivariate data are plotted on a graph, the points so obtained on the scatter diagram will be more or less concentrated around a curve, and that curve is called curve of regression. If the regression curve is a straight line, we say that there is linear regression between the variables under the study. If the curve of regression is not a straight line, then the regression is termed as curved or non-linear regression. And remember, we will be using this mathematical expression of y equal to a plus bx during the computation level. Usually in the application level question, you will be using this equation. And for representing these regression values in a graph, you will be using this equation for doing the same. Since we are not going to the graphical representation part, so you will not be able to represent the same in a graph by using this equation. Still, in the application level cases, you might be using this equation. We will come to that part during the application level cases. Let us go to the next one. Line of best fit, otherwise known as regression line. As I have mentioned earlier, we can represent a regression equations in a graph and you will be getting either a straight line or a curve, that depends upon the situation. So that regression line is known as line of best fit, and why it is called the line of best fit, that will be discussed. When the given bivariate data are plotted on a graph, we get the scatter diagram, just like the correlation method. If the points of the scatter diagram concentrate around a straight line, that line is called line of best fit. In the correlation part, we described that line as the perfect correlation line. If the dots in a graph concentrate in a straight line, it is known as perfect correlation. In here, it is known as line of best fit or regression line. That is, the line of best fit is the line which is closer to the points of the scatter diagram. This line is also known as regression line. So, a regression line is a graphical technique to show the functional relationship between dependent and independent variable. Next one, methods of drawing a regression line. There are a number of methods for identifying the regression line. For the time being, we will be studying two main methods. That is, one is freehand curve method and second one is method of least squares. First one, freehand curve method. Usually freehand curve method, as the name suggests, is just the easiest method of representing a regression line. A freehand curve method is an easy method for obtaining a regression line. According to this method, original data are plotted on a graph paper. Usually original data, when plotted on a graph, gives a wave-like curve, but it depicts a general tendency of the data. The independent variable is taken along the horizontal axis and the dependent variable along the vertical axis. We draw a smooth freehand line in such a way that it clearly indicates the tendency of the original data. This line is fitted merely by inspection and no mathematical accuracy is measured. That is why it is known as freehand curve. There is no formula or statistical criteria for drawing that regression line, and it is merely based on judgment. So let us discuss the same with an example, then we will get a clear picture. Right now we are going to measure the trend using the method of the freehand curve from the given data of production of wheat in a particular area of the world, and the details regarding the production of wheat in a particular part of the world along with its time and the tons. So let us draw the same in a graph. See, by plotting the same points in the graph, you got a line like this. See, the line consisting of dots is represented here. This line is drawn according to the details given in the table. And you can also see that there is a line. It is not exactly a straight line, but it is going through the middle of these points. Here this line is drawn to identify the trend of the given scenario. That is why it is known as trend line. And trend line is drawn in between the highest point and the lowest points. So here no type of accuracy or no type of mathematical method is used to draw the line. It is simply drawn in between the points plotted on the same graph. That is why it is known as freehand curve method, and we can't always rely on a trend line on the basis of freehand curve method. It may be sometimes a misleading value because it is not based on any mathematical methods. Still, it is the most easiest and widely used method for identifying the regression flow. Next one, method of least squares or otherwise known as curve fitting. Method of least squares is a method of drawing a regression line by applying principle of least squares. Least squares is actually a mathematical method for representing some numerical data in a graph form. The principle of least square is that principle which states that the line of best fit should be drawn in such a manner that the sum of the squares of difference between the known values of the independent variable and the corresponding values of it obtained from the line of best fit should be the least. I hope you didn't understand anything. The thing is that there is a mathematical method for representing the same so as to identify the value of the dependent variable from an independent variable. That is a basic concept. You are going to find out the value of a dependent variable from an independent variable using some certain set of equations. That is the simple meaning of methods of least squares. Regression equations. In the beginning I have mentioned that in every regression analysis you will be identifying or creating regression equations. Regression equations are the equations of regression lines. Regression equation is a mathematical relation between the dependent and independent variable. There are two regression lines and therefore there are two regression equations. One is known as regression equation on y on x and another is known as regression equation of x on y. So from here on we will be dealing with the application level cases, so just go through it very cautiously. First of all, let us discuss with creation of regression equation of y on x. Usually our analysis will be always based on two variables x and y, and you will be creating two set of equations. One is based on y on x and another will be based on x on y. So for the time being, understand equation used for y on x means in that case you will be finding the value of y and you will have the details of x. In simple terms, it means the y is an unknown variable and x is a known variable. That is the simple meaning of regression equation of y on x. Remember, regression equation of y on x is used to find when y is unknown. I hope you are following it. So, the first step in the regression equation of y on x is y minus mean equal to byx into x minus mean. In the first step in the setting up of equation regarding the regression equation of y on x is there is a relationship between y and y mean along with x and x mean including a function of byx. That is a simple concept of this equation. Actually this is not an equation part. From this you will be developing the actual equation. So here y and y mean, x and x mean, I hope you all are familiar. But byx, actually this is a function in regression analysis and byx is a separate function and you need to use another equation for finding the value of byx. So the equation for finding byx is n sigma xy minus sigma x into sigma y divided by n sigma x square minus sigma x the whole square. That is the equation for finding the value of byx. Remember the flows. Here we were dealing with regression equation of y on x. We use this set of equation when y is unknown, and remember, see y on x, so it will begin with y minus y mean equal to byx into x minus x mean, and see y on x, first is y, second is x, so byx, first is y, second is x, byx equal to n sigma xy minus sigma x into sigma y divided by n sigma x square minus sigma x the whole square. I hope you are following it. So from this one You will be substituting this value in this part, and on the basis of that you will be developing the equation. Sometimes you may be asked to find some numerical value on the basis of that computed equations. We will go to that section in detail while dealing with the application level question. So this is a regression equation of y on x. Sometimes you may be using another equation for finding b by x, that is covariance of xy divided by standard deviation of x square. I hope you know what is the covariance of xy and how to find standard deviation and x square. Any of these two equations which can be used in an equation. Usually you will be using this one, and this equation may be used very rarely depending upon the details given. If the details regarding identification of covariance of x and y and standard deviation and x details is given, you can use this one. Otherwise you will be using this one. Majority of the cases you will be using this equation. Next one, regression equation of x on y. Just now we have discussed y on x. Y on x means we don't know y and we have the value of x. So then what will be the regression equation of x on y? Here the unknown value will be x. See, and the equation will be just like the earlier one, but just a slight difference. See, in here y is unknown, so we begin with y. Y minus y mean equal to b by x into x minus x mean. Here x is unknown, so we will begin with x. X minus b equal to bxy into y minus 5b. These two part remember, but at the same time see, here it is b by x and bxy. Since it is a subordinate value, you might neglect the position of these variables. Remember, there is the position of these are very important. In case of regression equation of y on x, you will be using b by x, whereas in the regression equation of x on y, you will be using bxy. Remember, see, x on y, here first one is x, see, bx, first one is x. Okay, just like the previous one, here we need to find the value of bxy. So the equation for finding bxy equal to, the numerator in both cases is same. See, n sigma xy minus sigma x into sigma y minus sigma x into sigma y. The only thing that changed is the denominator. Here it is x is the unknown and y is the known. Since y is known, or we have the value of y, we can use the same in the equation. See, n sigma y square minus sigma y the whole square. In here x is a known value, so we are using the known value here, n sigma x square minus sigma x the whole square. These are the two main equations for finding byx and bxy, and at the same time there is another equation for finding bxy, that is covariance of xy divided by standard deviation of y square. So these are the main equations for finding the regression equation of y on x as well as x on y, and usually you will be developing two equations. Sometimes in the question they may ask to find the numerical value of a certain phenomenon depending upon the equation you have just computed. That will be the second part of the question, and we will discuss that areas during the application level questions. So just go through it, understand the concept, give relevance to the theoretical part, because you may be dealing with practical cases as well as theoretical cases, and familiarize the equations. We will discuss about the further cases in the next one. And here the b by x and bxy are the main functions in the regression equations, and it is known as regression coefficients. So be familiarized with these equations and cases. We will discuss next the application level cases and other adjustment cases in the next session.